All right, just to set my heart at ease, here is vectors number 1, geometric vectors, which I started the video for, and it does have a blank note for the last video. The note, I will add the video in here. There was a handout. Then when I go to the second one, I haven't listed what I've designated as homework from the Red Calculus and Vectors book, but as I've said, I'm going to keep adding in these blank notes, so I'll have a note, which is the completed note, and the blank note in case you feel like printing it off to fill in, because in vectors there's going to be some pictures and they're hard to recopy. All right, so next one is adding and subtracting vectors. This may be another little short one, but there's lots of stuff. So the first thing is I have designated these two as vectors, but I'm using lowercase letters instead of the from here to here capital letters. But I have stated they're vectors by putting the arrowhead over top. The next thing is I totally made up this for vector u and this for vector v. So I just decided to say that vector u is going in this direction and is this length, and vector v is in this direction and this length. So here is the first question or thing that we have to worry about. So vectors u and v, u plus v is formed by taking v and moving its tail to the tip of u. So I have to take u, which is sitting here, and I totally just recopied it at the exact same angle on the page. So this is u, and I have to take v and move v so that its tail is at the tip of u. And when you get that vector, this resulting vector, which I am going to color, let's go blue just for fun. That means that this is still vector u, and this is still vector v. Now it's u plus v, and we get this as the resulting vector, and we call it u, vector u plus vector v. And that is the triangle law of vectors, called so because you're making triangles, at least with two vectors. That way you have three sides. With more, you will make more and more triangles, but probably not show your work for every triangle. All right, so examples. For vectors a and b below, sketch a plus b and also sketch b plus a. And then it also says over here, for my personal knowledge, a and b are infinite cloned, meaning that I can just move these around as I want to. So you do not have to worry about this thing. In fact, my notation was pretty poor. And just like way back in calculus, I don't know where this stuff comes from. Oh well. All right, so because they're infinitely cloned, I'm going to take and do part 1 first. So part 1 is me taking a, see how it's infinitely cloned, and adding on b. So that means moving b, its tail, to the tip of a, and then I can dig out this. Again, just for fun, I'm going to color it blue and call it what it's actually supposed to be called, which is vector A plus vector B. And just because I really should, I'm going to remind you that this was vector A and this was vector B. So now if I go on to the second one, and I'll move this out of the way for a sec until I figure out how much space, how much space I need. The next one, part 2, is taking vector B first and adding on A. So that's a poor place for it. Adding on A means that I take A and I move its tail to the tip of B. And then I can take, having some issues today, I can take my line maker and do the little shortcut version. So instead of going from here to here, then here to here, I can say, oh, the shortcut is there. And that, I'm going to color blue again. There's a lot of trouble for something I didn't need to do. And I'm going to mark it using good form. So this one was B, vector B. This one was vector A. And the result is B came first. So B, vector B plus vector A. And then let's see if we can answer this question. How can we tell if vector A plus vector B is exactly the same? So is it an equal vector? And back to the fact that equal vectors are going in the exact same direction and are the same length. So is A plus B equal to B plus A? So do vectors work in the same way as normal everyday addition or subtraction? And how are you going to tell that? Think about that for a minute while I do a little bit of smartboard magic. And maybe this gives it away. But here's how you can tell. Yep, they are. So because my B plus A ended up being exactly the same length and exactly the same direction as A plus B, they are actually equal vectors. They are the same. Wish I would stop that. So I'm going to put this back together again, drag this separate, and move on to the next question. Now, I really like these questions. So I apologize if you don't, but they exist. Bear with me. So this question says, given parallelogram ABCD below, so this is a parallelogram, so this line is the same thing as this, same size as this line, length. This length is the same as this length. These two are parallel, these two are parallel. So right now I've got no vectors, but I'm allowed to state vectors because I can indicate direction with the letters that I can go in. So I'm going to dig out yellow to see if I can do this question. And I'm not going to use a ruler just because I can outline this. I would have had to have drawn this with a ruler. So it says B to A plus A to E plus E to D plus D to C. Can you determine the name of a single vector equivalent to all four of these motions? And the answer, I hope, is obvious. And it is, so I've gone from starting at B, and I've traveled up here, up there, down there, and I've ended up here. So this is the tail of a really poorly drawn line. And this is the tip. So these four vectors added together could actually be vector B to C, written with the arrow on top. Now the neat thing about this is as long as you've got plus signs, so there's a plus sign here, and there's a plus sign here, and there's a plus sign here, so it can't be minus signs, but as long as you've got plus signs, this really cool pattern emerges. So as long as this ending letter is the same as this beginning letter, which it is all the way through, and remember it's got to be plus signs, these kind of all cancel out, and you end up saying, oh, I started at B, and I ended at C. So that's something to keep in mind to shorten the fact that sometimes you don't always need to follow the picture. And that's why I like this stuff. So the next question, subtraction of vectors. So with vectors u minus v, so vector u minus vector v, that means vector u plus the opposite of vector v. So negative v, negative vector v, is the same thing as v, but in the opposite direction. And it's kind of the same thing with numbers. So way back when you first started learning negative numbers, 5 minus 14 wasn't 5 minus 14, which you might still be able to quickly calculate as negative 9. It was adding the opposite. So it's 5 plus negative 14. And it is exactly the same with vectors. So you're adding the opposite. So here's my example. Again, note to self, infinitely cloned. And so I have designated that this is vector C. So there we go. And I need to take D and I need to add on its negative. Now, do you remember how to do that? It means that you have to take this and you have to make it go in the other direction. Now, I'm going to find this very tough on the smartboard, probably as tough as you are on paper. So negative D is actually going tip to tail, so I have to change its direction and do that. So that's negative D. Here's C, vector C. Here's negative D. And I've gone tip to tail, so I've done exactly what I'm supposed to do. I've done vector C plus the opposite of vector D. And I can dig out my straight line maker, write down the shortcut. Not what I wanted to do. Struggling. What I want to do is change that to blue because it's handy. And then label it because I really should be labeling everything. So I'm going to label it with the smaller version, as in this one rather than this one. So that is a sketch of vector C minus vector D. So, do you always want to draw the picture is the question. As in, do you always want to draw the picture and go through the motions? So here is our last question for this note. So as you can see, they're a bit tiny. And, oh, my system doesn't work. So this deal doesn't work. And I don't even have all plus signs in this question. Well, that's not handy. So here's what you do. Well, I'm going to leave xy because it's a positive. And I'm going to leave yw because it's a positive. But this is telling you a direction. It's telling you backwards of z to w. So I'm going to go forwards w to z. So I'm just going in the opposite direction. And I still don't have, there's no special name for it. I don't have these little loopy things that I can do now that it's all plus. But because, and I don't even remember, oh, it is here. Because it doesn't matter which order you add vectors in, subtracting is different, but because it doesn't matter what order you add vectors in, that means I can take these three vectors and I can write them in whatever order I feel like without making a typo. So I still like my xy first, I think. And then I'm going to move this one in so that I've got a positive sign as I need with a yw, and then I've got this situation, so I'm happy. And then I'm going to move this one to the back, and I'm happy. Again, it's got to be a plus sign. And that means I don't have to worry about the y's, I don't have to worry about the w's, and I can write this as a single vector saying I'm going from x at the beginning to z at the end. And don't forget to call it a vector. All right, so that is your adding and subtracting vectors note. That was quick, and here's the stuff that I will put onto the Google Classroom. So ask questions if you need to.